Hello student, all of you welcome at Physics Point. Now students, I'm going to start uh, let us say buoyant force, right? So student, there is one important information for everyone. Student, don't skip the video. That is the first information for each and all candidate, right? And second is what the student, be punctual. Stay connected at Physics Point. Physics Point will help you a lot. Physics Point will help you a lot better according to your expectation, right? So stay Physics Point. I can say this is the platform. Hare Krishna student. Hare Krishna. I'm very happy to see you, my dear. Physics Point student will help you a lot. What is the topic student? Already I can say I have used in thumbnail, my dear. That is what buoyant force or Archimedes principle, right, my dear? Okay, so in today's class, I'll discuss in detail about, I can say, Archimedes principle, right? Okay, student. We'll go one by one. I'll discuss, students, all the points related to what buoyant force. Literally, I'll go very slow. Maybe student video will be long, but stay. I can say entire meeting, student, and don't leave the meeting as well. That is highly required. So now students, I can say for this condition, student, now I'm going to start buoyant force, or you can say Archimedes principle. Student, first I'll discuss, my dear, first I'll discuss Archimedes principle. So student, first I'll discuss, this is Archimedes principle. Yes, beta. First, I'll say Archimedes principle. Right, my dear? Okay, fine. So, students, for Archimedes principle, what is statement I can say, which is already stated by Jai Sri Sham student. I can say Archimedes principle, my dear. When an object is wholly or partially immersed in a liquid, what is student? When an object is wholly or partially immersed in a fluid, it experiences a buoyant force equal to weight of the fluid displaced. That is what, my dear, I can say Archimedes principle. What, my dear? Archimedes principle. Okay, so I'll write once here so that you can just remember what is this. Because in live class, student, I have to write everything. Live class, student, I have to write everything. Okay, thank you so much, student, for your love. What is student? When an object is student wholly or partially immersed thank you so much, student, for your love. Immersed in a liquid. So when an object is wholly or partially immersed in a liquid, it experiences, student, it experiences a buoyant force. What, my dear? It experiences a buoyant force equal to the weight of the fluid. Thank you so much, student, for your love. Fluid displaced beta. This is, student, which I wrote, I can say statement of Archimedes principle, my dear. Okay, after that, students, this will go through what is the buoyant force. Student, now onwards, Student, what I'll discuss, my dear, what is the buoyant force? What is the buoyant force? Okay, student, buoyant force, I'll explain with the help of example, my dear. Buoyant force, student, I'll explain with the help of example, my dear. Okay, let us suppose, students, here I'm considering, you can say there is a what, a closed container. This is what, my dear, a closed container, right? Okay, fine. In fact, I wanted to take a cube. Just understand this one, right? Let us suppose, beta, you can say this is the container which is completely, my dear, filled with liquid. This is the container, beta, which is completely filled with what, beta? Liquid. Okay, fine. Student, for if you watched, I can say, like yesterday lecture, which I explained, like pressure variation and different ways, beta, then you can understand easily this concept. Student, very good, my dear. So you can easily understand, beta, but still I can see you have to concentrate here only, right? Let us suppose, beta, as I said yesterday, here I'm considering, my dear, that is what, beta, you can say, Jai Sri Sham student. Okay, student, here I'm considering, beta, this is what, imaginary cylinder. These all are, I can say, my students known already. Now, beta, this is what, imaginary cylinder, which I consider what, under the water. Means you can say this cylinder also made of water only, right, my dear? Okay, fine. Student, I'll take it out, right? Student, let us suppose, just for understanding, beta, this is the container which is, you can say, free surface of water. Student, which is free surface of water, beta, I'm considering this is, you can take something, this height is what, L. This height is L. Okay, beta, very good. Now, students, I'm considering here, this is what, beta, you can say H. H is what, my dear? H is what, you can say, basically height of the cylinder. H is what, my dear? Height of the cylinder. Okay, students, here I'm considering, I'll take it out, beta, just understand here. Student, this is a cylinder. This is the imaginary cylinder of water, right? This is, students, here I'm considering, beta, this is L is what, my dear? L is what, you can say? L is what? You can say, bacha, this is height, upper surface of liquid with respect to what, beta? This is with respect to free surface. With respect to, beta, free surface. Okay, now, students, here I'm considering this is H, my dear. We concentrate, student, on lecture, right? So that you can get, literally, it's a very important topic. This is H. H is what, my dear? This is height of the cylinder. Okay, students, I can say next. So no, this is a surface of cylinder, contact with water. So, student, here I'm considering, force acting on the cylinder of water, which is nothing but, this is what, F1. What, a student? This is what, F1. Now, this surface of cylinder also contact in water. So, students, here I'm considering, this is what, my dear? This is, I'm considering basically F2. This is what I'm considering, F2, right? So, student, basically, we wish to find F1, F2 individually. Okay, now, students, what I can say, F1, beta, simply you can say, F1 is what? You can say, bacha, this is what, traces of liquid. Beta, one more thing I want you to tell you, bacha, this is what, A is area cross section of cylinder. A is what, beta, area cross section of cylinder, my dear. So, F1, beta, what I can say, this is, you can write, my dear, this is, what, bacha? This is pressure. F1, bacha, what I can say, this is pressure of liquid. Pressure of, beta, this is liquid into, beta, what you can say, pressure of liquid into, bacha, this is what, area. So, what is the pressures of liquid due to what? You can say, beta, this much pressures due to liquid. Okay, sir, what cause buoyancy? Okay, what is the cause of buoyancy? Beta, I can say buoyancy is nothing but Simply you can understand once student you can just replace from I can say concept of Archimedes principle. Good evening, sorry, good evening beta, very good evening. uh, so beta I can say that is a student, we can also connect density, but we'll go through slowly beta, right? So beta F1 is what? Pressures of a liquid into area beta. So you know pressures due to liquid, I hope all of you remember, that is lecture 1 beta, already I said. So student, I can write F1 is equals to, this is what? Density of liquid beta, this is rho into L beta, this is L into what beta? I can say L, this height into what? G bacha party into what? I can say A. So this is what? Beta F1. This is what beta? Sir, one questions came in my test and there were two tanker with different height, H1 and H2, and question was there be force same and top one answered yes. Yes beta, you can tell like that. Actually questions I didn't get it completely. There is what's question student? Sorry, one okay, H1 greater than H2. Height difference ne beta? Height difference. There is any beta condition of liquid beta? Like density of liquid beta? Sorry. If there is condition of beta density of liquid beta, then there is something I can change. Okay, hello, I am class 12th and literally until now my syllabus is completed. I don't know what to do. Can you please guide? Yes, student. Yes, student, I can guide you. I can guide you. Beta, just we stay in the live class. Just height difference, then pressure I can simply beta. You can write beta. You can write bacha. I can say someone radiant beta, just stay in the live stream bacha. I'll guide you beta. Definitely I'll guide you, my dear. So this is beta F1, right? Which I found from here. Beta, again we wish to find F2. I wanted to find beta what? F2 here. So find beta F2 here. The student take snapshot, my dear. So find F2 beta. Similarly at the what? Similarly at the bottom surface, the force F2 is what? Student, you can see similarly at the bottom surface, force F2 on the cylinder is what? In upward directions. So F2 beta, what we can write? F2 is what? Simply beta, you can say for entire beta length here. So beta F2 force, what you can write bacha party? F2, my dear. F2 beta, what you can write? Pressure of liquid as a point from beta here. Beta this condition, again I'll do one more diagram. Student, this is this is F2, my dear. This is F2. Height beta, I have taken H for the cylinder, and this is free surface of I can say container with respect to container D. This is L1 only. So what is F2 bacha? You can write pressure entire here, rho GH. So this is beta, you can say density of liquid remains rho G, and what's height beta? Height, this is you can write H plus L into beta, this is area, because you want to find what is the force. Now students, I can say now beta, this is F2. Now beta, I can say this is what? F2. Beta, we wish to find what is upthrust force. What is Archimedes principle, student? Archimedes principle is what beta? This is, I can say, experiences a buoyant force equal to weight of a fluid displaced, right, my dear? Okay. Yes beta, this is the fluid filled container. Yes beta, this is the fluid filled tanker. Correct bacha. Now bacha ji, you can say beta here we used to find what upthrust force. So what you can write bacha ji? Upthrust force. This is beta ji upthrust force. What beta ji? F2 is more beta. You can write F2 minus F1. So this is what beta? F2 minus F1 here. H plus L. H plus L into beta. This is density of liquid into G into A. Then bacha ji, what you can say? Again density of liquid into, this is rho Lg as beta, already be found previously bacha. This is F1. This is F1 bacha ji, right? Okay, my dear. So beta, this is rho Bg beta. Rho Bg. Beta, can you write your name here? Krishna 5577 beta. Can you write your name bacha? So F2 bacha, you can see bacha, this is, just open the bracket, my dear. Very good here. Today I can see now maximum connected good candidate. Bacha, this is what beta? Rho L G into A minus beta rho L G into A. I can say cancel. So this is what, my dear? Upthrust force you can write. upthrust force, beta I can write this is rho, beta what you can say A into H into G, and this is what my dear volume. Volume beta what you can say bacha, this is V is what beta volume submerge. Now bacha, so this is beta volume you can write here submerge or displace beta whatever you can tell anything. So this is beta you can say volume A and H beta product I'll replace by V only. So upthrust force my dear, this is rho Vg. Very good here, already I can see Aditya Krishna. Okay, Aditya Krishna, you are okay. Very good, Aditya beta. Very good job. I'm very happy to see bacha. Okay, now beta this upthrust force. So beta this is VB. Remember bacha, V beta either you can say volume displaced. What my dear? V can write bacha, this is volume displaced, or beta you can say this is what volume. This is what beta you can see volume submerge beta. Hi Prithviraj. Now beta this is volume displaced beta or volume submerge beta, you can tell anything. Now bacha this is I gave this is the just 15 minutes only buoyancy force. What's the buoyancy force? This is also known as what upthrust force. Buoyancy force my dear you can also tell upthrust force, right? This is what rho Vg. V is what volume replace or volume submerge. Sir, can you teach in Hindi? I think many students will be more comfortable. I'll try beta, sorry, now onwards, right? I'll try beta. I'll try, sorry. So this is student I can say condition. Buoyancy force nothing here, it's upthrust force, that's all. Buoyancy force nothing beta, what you can say, it's a basically kind of upthrust force. But beta there is something here which I wanted to tell you. Beta ji, which I wrote the formula, that is buoyancy force. Sorry, this is what beta rho Vg. Sir, I can also teach in Hindi bacha, but you know I'm more comfortable. I'll try. I'll talk beta Hindi also. Beta this is what I can say beta upward force on the cylinder due to what surrounding liquid. Beta what this is the upward force on cylinder due to what surrounding liquid is what beta the buoyant force, and equal to what buoyant force is equals to weight of the liquid in the volume displaced by the object. That's all. Bachaji, if we replace this cylinder by another cylinder, let us suppose, students, what I have taken, this cylinder, what I have taken previously, this is what beta, I can say made of water only. You can say this is what density of water. If you are going to replace, student, if you are going to replace here, I can say for next, another thing beta, you can say same size but different material. You can say this is aluminium. You can say beta this is what aluminium. Beta one is a water surface you can take, and other is what beta you can say aluminium, right? The buoyant force remains same. That is a beta I can say interesting point. What is sorry beta? Hello student, bacha I can say beta this is both have a different material bacha party, but what is the interesting point? Beta there is no change. What is it? I can say beta result. If we have a two body have a different material, same shape and size, then bacha what you can say buoyant force remains same. What bacha? Buoyant force sir remains same. Today class sir beta literally very interesting here. I'll teach I can say entire theory, then numerical only bacha party. Okay, now bacha it depends only on what beta, what is dependency of you can say bacha buoyancy, dependency of beta you can say what buoyancy, BUOU, buoyancy force, right beta. This is the first condition beta. This is only depends on what volume of the submerged object, not on the mass, on density. What student? This is only beta depends on volume of yes Krishna beta. Sir also solve please add the questions. Yes literally yes sir, advanced question only beta, little na beta I can say sorry maximum student na lacking in basic concept. So sir, first I'll teach entire theory, then I'll start illustration based on this, then main, then advanced. Yes, I'll do maximum question from Herodo beta, Herodo and SAV, so that you can enjoy, because I know about you, how you are. Sorry. So I'm just targeting classes because expectation of yours beta. So don't worry, I'll do everything beta. So this is what beta you can see. It only depends on what beta? Volume of the what beta? Submerge. What beta ji? Volume of the, you can say, submerged object. Not on beta, you can say mass and beta ji density bacha. Okay, fine. Then bacha ji, what I can say for this condition, beta, same thing, just I said like the beta, these are the basics things about buoyancy force. Now bacha, I wanted to discuss law of flotation. What my dear, I wanted to discuss law of flotation. In fact beta, today class na I'll give basics numerical and theory. I'll take one more class. In that class, I'll discuss only illustration of good illustration. You can say advanced, mains, Aerodog, and a bit multiple books of Pan India. So now, students, I'm going to discuss, that is, I can say, law of flotation. Interesting, bacha, and very easy. What bacha? Law of flotation. Law of bacha ji flotation. This is what my dear? Law of flotation. Okay, fine. So bacha, what is the law of flotation here? Understand bacha, with the help of, I can say, example, or you can say diagram. Let us suppose this is a container. Student, this is what? Container, right? Okay, in this container beta, just you can take condition like this. This is filled with water. Bacha ji, this is the, I can say, material. Few I can say inside and few outside, right bacha? Oh, Arab. Okay, all right. It's clean only beta, it's visible only, Harshit. Arab bacha, how are you? Where you was previously? Okay, all right, I'll write Harshit bacha. Okay. Now, but this is, I can say, bacha, this is buoyancy, beta, floating body. What is floating condition? You can tell, bacha, this is the body, bacha, this is initially a few what? I'm considering volume emerge, VI beta. I'll write here clearly. Volume emerge. Beta, you know what I said, what's the Archimedes principle? Buoyant force is what, beta? I can say there is what? Upthrust force. So just make a BDR of this one. Then, beta, you can write in these directions. This is what? mg force. Weight of the body. Students, in upward direction beta, what you can say, this is what beta ji? Buoyant force. Simple. Sir, it is very clear. Yes Krishna. Yes Krishna beta. So now beta, at equilibrium conditions, student, at equilibrium condition, right? Student, at equilibrium condition beta, what I can say, simple bacha, weight, what my dear? Weight is equals to, this is very good bacha, upthrust force. Weight is equals to what my dear? Upthrust force. So what is weight bacha? mg only here. So you can say this is mg. Got it? Okay, ara bacha. mg is equals to what bacha? This is, you can say, upthrust force, 1c bacha. So 1c already I said here. This is rho, density of liquid my dear. Volume emerge beta. Volume beta, what you can say? Emerge, right beta? Okay, and into what beta? This is what is g. Beta, here I'll use your one formula. I hope all of you remember. Already I said in lecture 1 of fluid statics. Density beta, what? Mass per unit volume. Mass beta, I can write density into volume. So this is what beta, I can say solids. So you can write here density of solids into beta g, V. This is what beta? V. You can see this is V total bacha. V2, S, sorry beta, S, sorry, force are equal. Very good Arab. I'm very happy to see Arab, sorry beta, very good response here. And one Krishna, these three are very active. These three candidates, Krishna, Arab, and I can say Swar, very much active here. Then you will enjoy here. Session will be long only, no need to worry. But I'll do every questions according to your expectation, my dear. V is beta what you can say volume total of the solid. This is what bacha Vg is equals to density of liquid volume immersed into G bacha. G cancel bacha, right? Beta, you know this is a very common question beta. Sorry, beta, this is very common question beta. This is a very common question beta G, right? We have to remember bacha. This is what I can see bacha volume emerge upon beta volume total is equals to what student density of solid upon beta what density of liquid. Density of solid upon what beta density of liquid. You know beta this is I can say one hero formula for beta law of flotation. What my dear? For law of flotation, right beta G? Okay, so this is beta things which you can keep in mind. Vi upon V. Beta no, this is sir, are you teaching fluid? Yes beta, fluid I'm teaching. Yes beta. Yes. Now I'll give you way. Yes. Arab, stay beta. Just meeting just started here. Classes beta. No, that's why I'm just covering those topics now which have a more weightage and I can say lack of confidence in the student. Right beta? So yes beta. JE will ask definitely here. I'll give you maximum question. Wait, I'll give it a question as well. So which I know what is VI upon VO. Beta ji VI upon VO beta this is what you can say fraction of volume emerge. Bacha ji this is VI upon V is what my dear fraction of beta volume emerged. Beta what I can say we can take area common and cancel. You can do beta. Oh jeet kira good bacha. Fraction of body in a liquid. You can tell beta. Bacha. So V upon V beta what you can say fraction of volume emerge beta, right? Okay, now bacha there are different cases which I can discuss about this. But before that beta I can say I wanted to add beta more point. What my dear? Buoyant force in a accelerating fluid. Yesterday beta I covered already pressure difference for accelerating fluid, right? Now students, what's the topic? Buoyant force in accelerating fluid. This is BUO buoyant force in beta ji accelerating fluid. Buoyant force beta what I can see in accelerating fluid. Buoyant force beta what I can see in accelerating fluid. Okay, fine. But I know there again here I'll take a little thing bacha party. Let us suppose bacha if lift I can see means there is a container. You can take bacha. This is the elevator. This is what my dear elevator. I can see beta inside the elevator there is a container. Inside the elevator bacha you can say this is a lift my dear, right? And there is what container bacha. Okay, fine. Now beta you can take this time lift is going in what upper directions with acceleration bacha ji a meter per second square bacha. Thank you bacha, God bless you for your love. Now bacha this is what in upper directions, right? And there is what you can see bacha container. This is filled with liquid. Sir, sorry sir, I couldn't come for yesterday lecture because I went out. Okay, it's fine. Just go and watch better. There already student Aditya Krishna, my dear, already student I uploaded, right? Lecture beta, I can go and watch my dear. Now bacha I can see this is up beta. So we wish to find what is the condition of acceleration for this condition. Simply bacha you can just make ABD beta. You can make bacha ABD. Let us suppose bacha if you make ABD here, then what you can say? Sir, this is beta I have taken this bubble here. Just you can take I have taken there is what imaginary body. This is what I can say water only. So now beta this is mg force acting in this direction. Beta you know this is what beta 1c. This is what you can say buoyancy force acting beta in upward directions. Beta entire system motion in what bacha ji? In upward directions with acceleration a. Uh, S bacha, S Aditya Krishna beta. I'm proud on bacha. I'm proud on you bacha. Student, here I'm going to use bacha using equals in NLM. Students, here I'm going to use using concept of pseudo force. You can think, yes, you can also do by pseudo force beta, but it's more easy bacha. Arabi no beta. I don't want to just add pseudo force. You can do correct beta. Correct Arabi beta. I'm proud on bacha. Using concept of beta NLM. NLM. I hope all of you know Newton's law of motion bacha party. So this is what, my dear? Summation of F net, which is equals to ma, right bacha? F net bacha, this is what? Motion in this direction bacha. So this is a larger force. I hope all of you know, because already I see it in the classroom. Driving force always more bacha. So you can write, my dear, this is Fv SS. Very good beta. Very good Aditya Krishna bacha. I'm proud on bacha Aditya Ara beta. This is Fv minus beta what you can say mc, which is equals to beta I can say ma, which is equals to beta what I can say ma, right bacha party? Okay, so beta you know Fv is what? Tell me bacha party. This is what? Density of liquid, volume beta, submerged or immerged beta into G is equals to what you can say m bacha. I can take common bacha. This is G plus A. Mass beta I can write bacha. Aditya Krishna, yes, very good Aditya beta. M beta what you can write? Density into volume. This is beta volume emerge. You can write volume Vi bacha party, right? Okay. So bacha party, you know what is the things here? This two are beta here remains same only. So this is what, my dear? You can say, because itself both are water. This is made of beta water only bacha. So density of liquid beta and volume emerge. Now beta you can see this is density of liquid into volume into beta, this is G is equals to density of liquid, volume remains same here, displaced into what, my dear? G plus A. This is beta you can say cancel. This G is you know beta I can tell you the formula directly here, but no, because now you are here only, but lecture can watch many students. So that's why I'm covering every topic in a slow manner so that each and everyone can understand. Arab Sharma because of pseudo force. Sir, if we fluid in elevator does not come out, sir, why? Pseudo force you can take, yaar. Beta, you can take pseudo force, beta. Arab, you can take beta. Now bacha party, this is G effective beta. What I have taken, if I can say your container which is inside the elevator, motion in upward direction bacha. Beta, I can say beta, this is cases number 2. Student, this is case number 2, my dear. Right. Here I'm considering elevator motion in what? Are beta, student, are you got clear? Beta, this is X listen bacha, I can say in A. So bacha, for this condition, are beta, you doubt clear bacha? This is mg bacha, right? This is what beta I can say mg. Once beta again here in a beta always upthrust force. This is beta, this is remains A. Student, again I'm going to use beta same thing Arab Sharma because sir same thing only, sir why again? Yes. I'm writing beta directly result bacha. Using beta again concept of NLM. Using beta, this is concept of NLM bacha. So you can say bacha, this is again here summation of F net, which is equals to ma bacha. Mg minus buoyancy force is equals to ma bacha. So mg beta again you can write here this condition. This is what? Minus fb beta g. ma minus mg beta. Just take minus m common here. fb beta g. This is you can take m beta g. This is basically g minus a. This is density of liquid v into g beta. Density of liquid into v into what, my dear? G minus a. You can say again cancel, my dear. So this is G effective is equals to what, my dear? G minus a. G effective is what beta? G minus A. Sir, can you do one shot for the class 11th mechanics, which is required for class 12th students? I'll try beta. I'll try my dear. I'll try my dear. That's why just I'm making those concept. Just I'm coming live to just discuss because these all are confusing and not much clear by students. Now, which I can say this is a thing beta which I have done. Beta what case 1 and 2. If what I can say buoyant force in accelerating fluid. So there is a condition here. There is a I can say conditions which I wanted to discuss. Like you can say. If your fluids, beta first I'll discuss concept here, then I'll beta go through numerical. Or better for now because I've done this. There is one more concept here which I wanted to discuss. Just I'll give it a straightforward numerical only. Beta there are 3 cases. Just I'm giving concept beta. I'll prove this all result. This is students case 1. This is beta what I can say case 1 bacha battery. Students here I'm considering, let us suppose density of liquid 2 beta, I'm just or you can say beta rho 2 is equals to 1. If density of both body remains same, then beta what you can come in? Sorry, tell beta. What is the level of liquid? What is the level of liquid beta? Tell bacha buddy. Level of liquid. Sir, this is high. Yes, Arab. Yes, Arab beta. Entire Arabacha, I can say entire concept 11th and 12th class we have to do with honest, right? Then we'll enjoy. So beta, let us suppose I'm considering here there is some situation, a piece of ice, right? You can say that is a floating. So beta, this is our condition of floating bacha. Piece of ice beta, I can say there is glass vessels. So this is what you can say for this condition. Level remains change. Label remains, you can say bacha, label remains unchanged here. Remains unchanged. But I'll discuss bacha, I'll discuss this concept in detail. Same level. I'm just going to tell bacha, this thing but I'll discuss yes. This is case 1 bacha, which I'm going to discuss you with the help of illustration. Now beta, Arab, come. What's the question bacha, Arab? A piece of Arabacha, a piece of ice is floating in a glass vessels. In a glass vessels filled with water. Filled with what, my dear? Filled with water, right? Beta, you have to prove. Beta, label remains unchanged. Beta, prove that label remain unchanged, right? Bacha, have a look. How can we do bacha? These questions. Beta, this is I can say case 1 here. You can say density of what? Both of the body remains the same. Then floating condition we can take bacha. Simple bacha for solutions. What you can take? Beta, let us suppose m is the what? Mass of the ice piece floating on water. So beta, you can say here at the, because this is the beta condition of floating. This is ice piece. This is what ice piece beta. Now you can see this is basically floating. This is ice piece bacha, floating on the what? Surface of water. So at equilibrium, so what you can say here, this is what? Weight of the ice beta which is in downward directions, weight of the ice piece, and this is what? Same thing bacha, just now I finished here. I'm just considering a numerical because of all of you bacha. So this is what you can see beta, buoyancy force. So simple beta, you can write this is what, my dear, weight of ice piece is equals to beta up thrust force. Up thrust force, right beta? Weight of ice beta, what I can say, this is a up thrust force. Weight is nothing beta. You can write, my dear, this is what mg is equals to what was that? This is volume immerged density of water into g beta. Mg beta, this is what mass of ice beta g. So we can write beta for this condition. Mg is what beta? Mass air. So simply bacha, you can see this is rho vg. So volume immerged beta, what we will get? Volume immerged beta g. This is, you can write m upon gg, cancel beta, m upon density of water. Students, say equations number 1, my dear. Say equations. Arab, if I what says sir, how to show you proof. Okay, Arab bacha. Yes, you can beta write your beta solution here only beta. I said multiple time Arab bacha. I'm very proud of beta. I'm literally feeling proud on you bacha Arab. B. Sarma. Student, it's a mail ID. B. Sarma. This is 9219 at the rate of gmail.com. Arab bacha, you can write your concern always here only. If you are solving beta, just I'll check my beta. I can say email. You just prove beta and just send me. So beta Arab, this is condition beta. What I can say, weight of ice piece is equals to what beta? Up thrust force. Weight is mg beta. This is volume immerged density of water into g. Beta, I got here volume immerged is what? Mass upon density of water. That's all. Now beta, Vi is what? Volume of ice immersed in water. When ice melts, then beta, if ice melts, then volume will change beta. So what you can say? Let us suppose I'm considering beta for next condition. If Vi is the what? Volume of ice is immersed in a water. When ice melts beta, if ice melts, student, when ice melts, if ice melt beta, I'm considering, let us suppose, let V is the volume. This is what V is the volume after melting ice, my dear. After melting ice, my dear. Okay, so bacha, here what can I write here? Volume is what? Mass, because entire becomes water only. Entire, because this is beta, I can say container in which there is a water, right? And there is what? I can say piece of ice is floating. So entire ice melt bacha party. Level, no. I don't know. Level remains same. Already I said. See here. Rho 2 is equals to 1. This is the condition after melting. Because ice becomes water. Arab beta, ice becomes water. That's why I said this is the case 1. Beta, this question which I'm solving now, this is JEE main PYQs. Not means advanced PYQs. It's a very intelligent questions. Not now. It's very long back question already asked by JEE. That's why I have taken initially rho 2 is equals to rho 1. Because if ice 1 melts, if beta ice 1 melts here, then what you can say, entire ice becomes water. That's why I have taken what? Density remains same. So bacha, level B remains same bacha. Volume is what beta I can say? This is m upon density of water. You can tell beta. Question number 2. Sir, but ice density 0.9. Now everything applicable after melting beta. Arab, you correct? Arab, you correct bacha ji. Arab, you correct my dear. No, that's why no beta. I'm just this now. It's been a previous question, my dear. Previously they asked, but nowadays these all are basic illustration to be part of class, bacha. Now bacha, just take beta ratio of these two. Beta, you can take bacha ji what? You can say ratio of these two bacha. Then beta, what you will get? Just beta divide. Ara bacha divide first by second beta. Then what I can say, volume immerged is equals to volume V only. That's why beta, what I can say, volume remains same. If we have a density, both I can say floating body in liquid remains same. Ara beta, Arab got it beta? Arab beta, you got it? Krishna, sir, but what is the equilibrium is attained and amount of ice melting, amount of ice forming? Okay, Aditya Krishna, but listen, what I said, we'll go through again here. Don't be hurry. No need to be a hurry here. That is the point, bacha. What question says a piece of ice is floating, means condition of flotation. Condition of flotation. What you can say? Density of body. Beta, you can write easily here. Upthrust force is equals to what? Weight displaced of the body. That's all. Okay. Aditya Krishna, maybe you got it. Arabacha, you got it now? Okay, fine. Now, bacha, have a look next illustration. Arabacha, have a look next illustration here. Okay. Arabacha, here I'm considering bacha, that is, you can say cases 2. Aditya, only possible for isothermal. Oh, temperature constant, you're considering. Now, beta, this is case 2, beta. This is case 2. Okay, wait, very good, Aditya Krishna, beta. Beta, God bless you for your response here. Beta, next question, cases 2, bacha. Case 2, beta, what I'm considering here, density of, you can see, beta, second body is what? Density of one body. This is more. Beta, for this condition, I'll prove this result here. Level will decrease, bacha. What, beta, I can say, level will decrease. Level will what? Decrease here. I'll prove, bacha, party with the help of example here. Let us suppose, students, here I'm considering same thing, bacha. A piece of ice having a stone frozen, having a beta, this is stone frozen in it, right? Floats, beta, I can say, in a, but I know these all questions in normal classes, I can say live classes, physical classes, I never give a statement, just I can say cause and beta, data beta, and just go through this. But in live classes I have to just give everything. Glass vessel, beta ji, glass vessel filled with water. What, my dear? Glass vessel filled with water. Okay, how will the sir, where physical class? Beta, in Bangalore, beta, I'm in Bangalore, my dear. Level of water in the vessel change when the ice melts. When the beta ji ice melts. When the what? Ice melts, beta. Okay, again I'll read, beta, question once. Arabacha, today I'll give you, right, end of the session, beta, contact number of physics point. You can contact directly, bacha, right? Because Arab, you are a good candidate, right? Arab, I can sure, there are 3 candidates more active. Arab, sure, and I can say one is Aditya Krishna. I'll give you a contact of physics point, bacha, Arab, today, end of the class. A piece of ice having a stone frozen in it floats in a glass vessel filled with water. Okay, how will the level of water in the vessel change when the ice melts? When the ice melts. Sir, when numerical for us to solve? I'm solving numerical for you only, na, beta? Okay, do you want to try? Do you want to try this question, Arab? Arab, do you want to try? Okay, you can try this question. You can try it. Ara beta, do you want to try this question? Okay, anyone want to try this question beta, or I have to do? Arab, Shor, Krishna, Aditya Krishna, anyone want to try these questions, or I have to do? Okay, I have to do bacha. Sir, you do, I'll keep doing. Okay, beta. Okay, bacha. Okay, beta. Then you have just beta verified answer, right? Okay, fine. Now bacha party. Beta, what's the questions here? Already all of you got it here. So beta, just I'll turn the page. Beta, have a look solutions. Right. What's the question here? Just understand first by the diagram bacha. You can say this is the container, right? In this container, students, you can say this is what? Beta, water filled. Already mentioned in the question, my dear. So, student, you can say for this condition, there is beta, I can say ice cube, which is floating condition, beta already mentioned. Inside the cube, beta, there is what? Stone. You can beta take out and you can understand like this. You can understand like this, bacha. This is stone, bacha party, which is frozen in the ice cube. What we have to come in? If entire I can see ice melts, then what's the this coming on level of water? Coming on what level of water? So beta, I can say initially here. Initially, students, I'm considering if I can say ice and stone both are together at equilibrium condition, bacha. You can write beta in this condition here. This is what M1 beta. Here I'm considering mass of ice. M2 students, here I'm considering mass of stone. M1 plus M2 into G, dear. Very good, beta. Thank you for your love here. M1 plus M2 into G, bacha. This is what? You can simply say, bacha, buoyancy force. You can say, bacha, what? This is the buoyancy force. Okay. So, bacha, you can say at equilibrium condition, my dear. Student, at equilibrium condition. Bacha, you can say, my dear, this is M1 plus M2 into G is equals to what, bacha? You can say volume immerged density of water into G, beta. Right. So beta, here you can find G and G cancel, bacha G. What is the volume immerged here? So this is M1 upon density of water plus, sorry beta, I'm not getting answer from your side, beta. Sure, are you there? This is beta M1 upon what? Density of water, bacha. M1 upon what? Density of water. This is beta, I can say condition of our initial. Condition beta for initial, beta, I can say this is what? Condition of equilibrium. Now beta, just I'm going to tell next point. You can tell beta, this is step 1 for this question. What's the step 2, my dear? What's the step 2, my dear? Okay, for this condition, student, I'm considering here ice completely, beta. Ice, you can say what? Completely convert in form of, you can see water, right, bacha party. So beta, for this condition, what I can write? For volume beta submerged, this is what? Simply beta, you can write beta, this is volume, you can take beta G V1 mass upon what, beta? Density of water, beta. Let us suppose equation number 1. Then beta, volume of stone, I'm considering beta V2. This is what? M upon bacha party? Density of stone. Density of stone, bacha. This is what? You can say equations number 2. This is what, beta? Equations number 2. Beta, I hope all of you remember density of stone is what, beta? Greater than density of water. Density of stone, beta, what? Greater than density of water. But I know density of stone, what is this here? Density of stone, beta, I can say 2200 to, beta, there is a variation up to 3000 kilogram per meter cube. Density of stone, bacha, this is a variation here. So you can see, my dear, density of stone is what? Greater than what? Density of water. Beta, just add this to here. Then what you can say? V1 plus V2, which is definitely what? Less than volume immersed. What you can say? V1 plus V2, summation of these two, bacha. What you can write? Definitely what? Less than, beta, volume of immerged. So what is the conclusion, beta? If we now, beta, I have taken, there is what I can say, bacha, stone. Maybe they will take another material as well. So if something I can say inside the ice cube, yes, Aditya Krishna, beta. Yes, Aditya Krishna, beta. So what, beta, I can say? Density, or I can say rho 2 is what? Greater than rho 1. Rho 2 beta, I can say this is a material, and rho 1 is what beta? Sir, I know all the concept, but in questions I always lack. That is the wide na beta. Students, I can say, sorry, physics point here, always I'm looking growth of students. Due to this, my dear, you can't imagine, always student, what I'm doing, just start the class from zero level. Zero to beta hero. This is the physics point beta, I can say, methodology of teaching. Always start so that all of each and everyone can get a result. Yes, beta. Sir, I did not do mistake. Okay, Arabits. Don't worry. Just these all are beta. Arabits some discussion question already Jay asked. Bacha party. Beta next question here. I can say bacha this is beta next question. Solid. Beta note beta questions. Sorry, beta note questions here. I'm telling you. Beta this is beta G solid float. A solid beta floats in a liquid. Student, solid floats in a liquid of different material. In a liquid of beta G different material, right beta? Okay. Beta same analysis we can take bacha party, right? So beta here we can connect what is the tendency bacha party. Beta this point I'll discuss beta I can see in detail. So beta for this condition we have to comment whether the level of liquid in the container will rise or fall when the solid melts. Beta what you can say bacha, solid floats in a liquid of a different material. We don't know what's the dense nature of material. Different material you can take. Whether the level of liquid, whether the beta G level of liquid will rise or fall. The beta we have just beta this comment here only. Comment this only. So beta you can take for the solution conditions. M is what beta? Mass of material. M is what, my dear? Mass of material. Sir, can you give numerical data? Okay. Beta after this numerical beta, Arab I'll give you data of numerical only. Yes, beta. This is the beta. You know these are the beta condition. There is beta. There are 4 beta. Label rise. Okay, Arab beta. I'll see beta. Arab beta. I'll see beta. Right. So beta I can see for this condition. Rho 2 beta. Rho 2 beta I can see this is what? Density of liquid formed by what? Melting of the solid. And beta this is no beta I can there is condition here. If beta I can say this is what? Rho 2 is what beta? Rho 2 is what? You can say less than rho 1. Then beta this condition. What you can say? Label will rise. What bacha ji? Label will rise. Okay, beta this is one more I can say beta. There is just I'm going to just skip numerical here. Next bacha, let us suppose if density beta both body equal beta ji. Rho 2 is equals to rho 1. Maybe already done? No. This is case 2. Case 1. Yes beta, this is flotation here. Already done. Li bacha body. Do beta some question here because it's a demand of Arab bacha. Arab beta do question bacha. Do beta question everyone. Yes sir, got it. Very good. Sir, my internet very unstable, sir, because of there is a power cut at my okay, power cut beta. Manage bacha if possible. Otherwise I can watch beta lecture later also bacha. So beta just do the question everyone here. Be active everyone. Student everyone be active bacha. Do everyone questions. Beta you can take density of ice. Density of ice beta 900 kilogram per meter cube. Density of water beta all of you know, but still I'm writing 1000 kilogram per meter cube. Find fraction of volume of the piece of the ice outside the water. Find fraction of volume of ice outside the okay, Aditya sir, I got it. 1/10. No. Your answer is wrong. Maybe. Krishna beta. Okay, give me time to think. Bacha. Krishna. Okay. Krishna may be correct here. Correct, bacha. Krishna, correct, beta. Okay, have a look solution, bacha. What's it? 0.9. Okay, sorry, 0.9. Sorry, 0.9. Okay, fine, Krishna, beta. Wait, Krishna, sorry, bacha. Okay, Arab, sorry, 0.9. Okay, these three are, I can say, regular responding in the class. Very good, bacha. I'm very happy to see. Okay, beta, solution here. Have a look, bacha. Just, beta, we'll go through directly formula here. Just now I calculated, bacha. What is volume emerged by what, bacha? Formula, what I gave here? What I gave you, bacha, party formula, volume emerged. Yes, beta. Volume emerged, beta, upon volume, beta, I can say actually. What, beta? Density of solid upon what? Density of liquid. Okay. So, bacha, just will go, student, I'll use, beta, this result directly. Volume emerged upon, beta, volume is equals to what, bacha? You can say density of material upon density of liquid or water. So, beta, volume emerged by V, beta, this is, you can say 900 upon 1000. So, beta will get, this is what, basically 0.9. Oh, this is not answer. 0.9 is not answer. Not answer of 0.9, bacha, party. Fraction, they ask what? Fraction of the volume outside the water. What they ask? Fraction of ice outside the water, bacha. So, what's your answer, bacha ji? Fraction of 0.9 inside the water. Yes, Aditya Krishna, beta. Yes, beta, Aditya Krishna. You correct, beta. 0.9 inside the water, beta ji. So, fraction of volume outside the water. Outside the water, beta. So, this is what, beta? You can say fraction F is equals to 1 minus 0.9. Oh, very good, Aditya. Yes, you already responded with 0.1. Very good. I'm proud of bacha, Aditya, beta. Krishna is a topper of today live. Okay. Yes, correct. Krishna was correct. Yes, beta. Correct. Good, yeah, good. Next question. Now, this is, I can see, demand of Arab. Sir, you can give question based on numerical so that I can see myself where I am. Next question here. Bacha party. This is a beta J questions PYQs, but I forget exactly Arab beta when ask J this question. Beta questions again here, I'll just not write much. I will give beta data only. You can tell beta density of water. You can take my dear 1000 kilogram per meter cube, right? Beta in the questions what mentioned, bacha, as I remember, beta you can say density of water. Yes, 1000. Density of bacha material. Density of beta you can say material. This is you can take beta 13.5. This is you can take 13.5 into 10 to the power something. You can take bacha 10 to the power 3. Very good bit. Thank you bacha for your love here. Kilogram per meter cube. Okay. Now bacha, what's in the question here? That is the main point of the questions. Beta ji, such that 4/5 volume in the water and 1/5 volume in the liquid. Beta ji, what says 4/5 volume in beta ji water, right? And 1/5 volume. 1/5 volume in beta ji air. In beta ji what you can say No, liquid. The air we have to find. In student, this is the liquid. Find density of metal. Find density of metal. Find density of metal. Oh, this is a question like that here. This is density of water. This is, you can say, density of liquid. Find बच्चा जी density of metal. Sorry beta, did you already have done this question beta? Okay, beta I know. I'll also explain here this question. Didn't understand question sir. Okay, I'm telling beta again. You can tell beta, this is a container. Diagram beta, you can beta understand. Beta, this is a container, right? This is a container beta. There are two liquids here. There are two liquids. Maybe you got it beta. There are two liquids beta. You can say this is, you can see there is a different, just I'm calling beta rho 1 rho 2 here. You can understand. Beta, this is rho 1 beta. You can say this is rho 2. So beta, definitely here you can see this is rho 2 beta. This is what you can see rho 1. This is a, I can say beta material, or you can say floating body. So beta, floating body beta, just you can say beta, this is the volume 1/5. Okay. Okay, sir. Now understand. Okay, Krishna. Okay. Ara beta, wait beta. Also, beta, then I can tell beta party. Maybe Ara beta. Just wait. So this is the question beta party. Everyone, do here once. Then I'll do beta party. Then I'll do beta. Okay. Ara already solved, so I have to do. Ara beta, have a look. Ara, so look beta, my solution. Ara bacha, what you can say, total upthrust force. What bacha? Total upthrust force. Beta, there are two upthrust force. Beta, I can see one on beta this part and one beta this part. So you can write my dear here, total upthrust. Total upthrust force is equals to beta weight of metal. My dear, weight of metal. So upthrust was beta, though you can see beta F1 plus F2. Student, you can write this is F1 plus F2. It's nothing but what we dear, you can say mg. F1 beta, I can write rho bg here. F1 beta what? I can say density that is mentioned here. 1000 bacha party. So density of rho 1 into beta, I'm calling here V1 into G plus beta G. Rho 2 V2 into G is equals to beta mg. G, student, you can say finished. So beta rho 1 V1, rho 1 V1. I am new to life, sir. Okay, you welcome beta. Then how can I help you, student? Tell me please. Rho 1 bacha G, this is rho 2 V2 is equals to mass beta. Student, here I'll use bacha party formula beta. Next, what my dear, I'll continue beta same calculations. This is my dear, you can say rho 1 V1 plus rho 2 V2 is equals to m bacha party. Rho 1 V1 plus beta G, rho 2 V2 is equals to beta density of, I can say beta material into beta V only. This is beta already mentioned here, 4V by 5. So rho 1 beta how much? 1000 ara bacha, 1000 into beta 4 by 5. Ara beta, I'll write one more. 1000 into 4 by, this topic of fluid mechanics is going on. Beta, this is Archimedes principle, my dear. My dear, Archimedes principle beta. So this is beta, I can say 1000, 4 by 5 V plus beta G, V by 5. Sir, how can I contact you? Okay, beta, you can contact me, bacha. Just stay in the meeting, beta. I'll give you physics point contact number, beta. Stay in the meeting, beta. Once class, I forget fluid as studied almost 1 year ago. No. I'll help you, bacha. Today, student, I'll give you contact number of physics point. Stay in the meeting. If before terminating live session, bacha, I'll give you contact number of physics point, beta. Right, stay in the meeting, bacha. Still in the live session. Beta 1000 4 b by 5 beta b by 5 beta. And what's our beta density is mentioned, my dear. This is 13.5 into 10 to the power 3 beta. Density of metal beta V, you can say cancel everywhere. Beta, this is what you can see beta 5 to the. This is 200 beta into 4 plus beta g. This is, you can say 135 into beta 10 to the power 4 upon 5. Density of beta, this is what you can say beta g 800. Beta, just you can take 135 into 10 into beta 10 to the power 3 upon 5 bacha ji. This is what beta cancel here. Fine beta, you can solve beta. How much coming beta? Ara bacha? Ara beta, how much coming here? Density of Arab. Sir, can you give me tuition? Yes, Arab available. Yes, beta available. Tuition available. Online tuition available. Bacha. Krishna. My answer also beta coming same. Beta. Yes, beta coming same answer beta. 3500. Student online beta tuition available yaar. Beta don't worry. I'll take beta your tuition. 3.5 into beta 10 to the power 3 bacha. 3.5 10 to the power 3 bacha. This is what? Kilogram per meter cube beta. So density of metal Arab and Arab, I can say Aditya Krishna. Beta, both of you correct here. I'm feeling proud in the live session. Literally both of you genius beta. Hats off beta. I can say I got Arab. Yes, my beta same answer. Arab. Yes, I got same. Sir, where are you teaching only Arab? No. I'm teaching. This is a Arab beta like you also he corrected. Beta like you bacha Arab also connected here. So I'm teaching everyone. I'm calling Arab because Arab is responding the answer beta. You can respond me answer of the questions. Beta I'll also call your name bacha. Okay, J means 100. Arab in which class you are? Tell me first. Arab bacha tell me first. In which class you are? Aditya Krishna beta, God bless you. Arab, in which class you are? Maybe 11th, no? Yes, you said. I forgot. Okay, fine. Very good, yaar. J means not clear. Arab, you will create history. Got it. Arab bacha, you will create history, state physics point, state physics one beta. That's why I decided today I'll give. Because yesterday I was also watching to you. Literally, it was beta in the live session, you know, how few students behaving, but how you connected last, this is maybe your 3 days. So literally I'm impressed in you Arab. So I'll give you contact number of physics point, stay in the live session. I'll avail you tuition as well. If anyone want to tuition for 11th, 12th, mains, advanced, I'll avail. Online mode beta, I'll avail. Already I said bacha, everyone. Everyone. Beta, if you remember, what? Beta, my one classroom student, you know beta, he secured 100 percentile in JEE mains. 100 percentile beta. Aditya Krishna already know. Right? What is the schedule today in this live? Beta, if once I'll finish the Archimedes principle, theory almost I finished. If I'll finish numerical according to my expectation, then student I'll beta just stop the classes. So beta, no, one student already here. You know, in advanced beta 3301 beta in JEE advanced. Finally beta he got college beta what I can say IIT Roorkee bacha EC Electronic Communication Engineering. I think I am here just for ignoring. No. You can see this one is a platform. It's a emotion of I can say students and parents. Everyone most welcome bacha. Just here you have just stay. You will get everything bacha. I'm the people, you know. My teaching methodology only based on result orientation. That's all. Stay at physics point, you will get everything bacha. Today there are many students. Yes. Sorry, you will just teach na slowly here. Sorry beta, you can teach slowly here. Maximum beta definitely will connect to you bacha. Sir beta, next question here. Beta, do beta, everyone next question here. Yes beta, sorry. Sir, okay, okay, yes, yes, beta. Now, beta, good, beta. Next question. Can you please tell me some important topic for class 11 physics? Beta, first you have to do beta very good grip, beta. Entire mechanics. I can say kinematics, NLM, friction, work power, energy. That's all. Maximum thing you can take in consideration. Then they will go ahead. You can do entire beta physics. Now, bacha, what's the question, bacha? But you can see there is what? A wrapped wood. What are a bacha? A wrapped wood, beta. Density of beta, I can see this is wood. You can take beta 600 kilogram per meter cube. 600 kilogram per meter cube. Mass, beta, I can say mass is floating mass, beta. Mass of float. This is, you can take it as 120 kilogram. What, my dear? This is what basically 120 kilogram floats in a water. How much weight can be put on the raft to make it just sink? It about questions here. How much? I can say, sir, Arab, where do you study? Sir, continue. I study in Delhi school. Yes, increase your volume. Okay, okay, fine. I have to use beta. I can say a headphone. Wait. Today I forget, yeah, to just connect. Just beta, give me seconds here. 10 second beta.
Okay, so now is it audible, everyone? Just tell me, everyone, audible, visible. My audio video, everyone, please just update me. Write in chat box. Anyone from all of you? Audio video, visible, everyone. My audio, beta. Okay, yes, okay, okay. Good, sir, beta. Beta, God bless you for your reply, bacha. Beta, what question, bacha? How much weight can we? How much weight can be put? Can be put on the raft. Okay, pain finished. On the raft, beta right here, Jai Sham owns. It's new pen beta G. Okay, on the raft to make it sink, to make it just sink. Yes, beta. Uh, yes, beta Jai Sham. Sir, so time Arab. I study in Manipur school. Okay. Jai Sri Sham Aditya Krishna beta Aditya beta Jai Sri Sham. Okay, 80 kilogram. I'm getting. Okay, okay, beta. I'll also do bacha. I don't know what's answer beta ji. Have a look, beta. Arab. Everyone student. Have a look, student. So what's the question? Simple bacha. We wish to find. You can take beta consideration like this. There is a body. Beta. You can see there is a raft which is in the condition of floating. Right. Beta. Let us suppose this body mass beta. I'm taking m1. Okay. Aditya Krishna beta. Same answer. Oh, who is Aditya Krishna? Aditya Krishna, everyone here only, beta. What is the mass I have to place, beta? I can say M2. What is the mass of M2 I have to place here so that body can it just sink, right, beta? So you can see, beta, weight of the raft plus external weight is equal to what, beta? Upthrust on 100% volume of the raft, beta. So simple, beta, you can see at equilibrium. At equilibrium. What beta is 120 kilogram? Beta already mentions 120 kilogram plus m into beta z is equals to what beta? This is 120 upon beta 600 into beta 10 to the power 3 into g beta. This simple here. Uh, now बच्चा जी बस just solve beta further यार. G beta, you can say cancel beta G, right? What is coming, bacha? What is from here, bacha? 120 plus M, bacha. Beta, you can say this is 1, 2. Beta, this is, you can say 1200 by 6. So, bacha, you can say this is basically, mm, beta, you can see here 6, 200. Uh, M is coming 80 here. Okay, I got answer already. I got 80 of R.S. Sharma. Sir, can you say how much fees do you take? Arey yaar, what is this? Everything talking. I said na, I'll give you a personal number. I can't disclose anything over here. First, write your name. I wanted to call you by your name only. Arabita, I guess Arab and Krishna got same answer. Arab and Krishna got same answer, yaar. Arab and Krishna got same answer. Arab and beta Krishna got same answer, yaar. Okay, yes, sir, I got. Oh, very good, very good, very good. Aditya Krishna Bachcha. Okay, beta, have a look next here. Have a look next bachcha, buddy. Next, beta, I can see I'll discuss here. This theory, beta, already I covered. Yes, yes, good. Oh, Arab, you first. Very good. Very good, beta. Very good, yeah. I'm very happy to see, beta, everyone. All of you, beta, welcome at this one there and stay blaze, stay calm, and follow BK Sir. You will get everything which you want. Sir, my name is Raju. Okay, Raju. I'll call you by name, beta. Okay, what's the next beta? Other questions here? Beta, I can take. This is the container. Raju, Arab, Shor, Aditya Krishna. These all are, I can say, rock of the class. I can say two people as beta. I can say too much. I can say, which are like active in the class. Arab and Aditya Krishna. Arab being in 10th class, beta, I'm literally feeling proud with Arab on you. Literally, beta, Arab, I'm feeling proud with on you, beta. Okay, this is better conditions, right? You can take better container about motion in upward direction, bacha. This is a meter per second square. Okay, Raju beta. Answer it. Yes, I'll give it information there. Aditya Krishna which standard? Aditya Krishna beta, I don't know. Aditya Krishna can tell beta. Yes, yes, Raju, you can take beta. Okay, beta. Now I'm just calling but some data here. What is the mass of the body? Beta mass you can take beta g that is 1 kilogram, right? Beta density you can take care. Density of the body beta. This is a zero point 0.8 kilogram per meter cube. Jai Sri Krishna, student, woman. Okay, sir, what to find? Beta, for these questions, beta, what I can say is held stationary with the help of string. Beta, what's the question here? This is a container. Inside the container, there is a block. This block beta held stationary due to this string. This block beta held stationary due to string as shown in the figure. The tank accelerations we have to find. Beta, tank. No, beta. You can take beta. This is another question here. Tank beta acceleration I'm giving you in upward direction. This is 1 meter per second square. This is what, my dear? 1 meter per second. I'll repeat beta question again here. Raju, Shor, Aditya Krishna, and beta, what's the name? Arab. Beta, listen question carefully, bacha. Beta, this is, you can say, material. There is a block. There is a block beta, which is held stationary because of the strain. Entire setup beta motion in upward direction with what you can say acceleration a 1 meter per second square. Beta find following. Students find following beta g. Find beta g following. Beta, what is first one here? The tension in the string. Student, the tension in the string. Beta g, the tension in the string. Now, beta, this is, I can see in part 2, beta, what you have to find? If the string is now cut, oh, interesting questions here. If student string is now cut, find acceleration of block. Interesting, beta ji. Find acceleration of block beta. Okay, this is a question here. Do everyone sir? What to find, sir? Yes, I wrote beta. Sir, I wrote beta. Tension in the string. In it, beta, what's the question? I hope all of you got. This is string. I can say block remains stationary, bacha, due to a string only. First case, you have to find tension in the string for this condition. Second case, beta, sure, you have to find acceleration of block. If you will cut the string. If a string is now cut, then find acceleration of block. If you want try beta, okay, tension 10.2. Okay, sure, beta. I'm going to solve that. Student, everyone, look attention here. Look my solution, bacha. So, beta, what's the question here? You can see beta initially. Just beta make ABD. Students, first I'll make FVG of block. FBT of block beta. So, beta, this is ABD, beta. You can see one's force. Always beta, upthrust force here. So, this is a direction beta ki one's force. Okay, now beta, this is Sir, Aditya Krishna, Arab, Raju beta. This is beta. I can see beta in downward beta ji. This is, you can write beta mg plus tension beta. And entire system beta what? Motion beta in acceleration A like that beta. Right? So beta, you can say for this condition, upthrust force is what beta? Upthrust force is what? Tell me everyone, what is upthrust force? What is weight beta ji? Mass 1 beta. What you can write? Weight is equals to. So simple bacha, you can write equation using bacha. Use beta summation of F net, which is equal to me bacha ji. So you can say beta this is thrust force minus tension minus beta ji what? Mg is equals to me bacha. So you can say this is a thrust force minus T beta and mg beta nothing here. Beta they mention beta here. You can take my dear G is equals to 10 meter per second square. So F minus T beta minus mg is equals to beta 1 into 1 beta 1 only beta. So you can say Fv minus T is equals to 11 beta g. So we have to find a beta buoyancy force. Beta what we have to find? Buoyancy force here. Okay. So beta buoyancy force here I'll find beta. So what is the buoyancy force beta? Tell me everyone. This is what? Volume into beta what? Density of water air, system beta in motion in upward direction beta. So density of what is required? Beta, I'll find from here na beta. We have to use specific gravity. Yes, Aditya Krishna beta. Aditya Krishna, very good beta. I don't have a notebook. Okay, fine. Okay, beta. This is beta, I can say what? M into it. This is just now beta, I finished na beta, beta. G effective if motion in upward. G plus A beta party. Right. Beta, you can write beta party here directly. This is what? Beta mass. What is volume beta? Ji, tell me everyone. What is the volume beta? This is what? 1 upon beta 800. Now beta, this is beta mentioned here density. 0.8 beta. So what you can say beta? This is 1 upon 800. Now beta party. Okay. Into beta, what is the volume of water beta? This is 1000 beta G. G plus A beta. How much? 10 plus 1. 11. Okay. Yes, correct, beta, beta, sorry. Bhuvan, sir, if you don't mind, please tell me in Hindi. It will be easy for me to understand. Oh, Hindi. Okay, Hindi. Hindi. What is Hindi, beta? Easy, beta, woman. Okay, I'll try, beta, woman. Woman, I'll try, beta, ji. Okay. So, one C, beta, what you can say, beta? One C, beta, how much coming, beta? Tell me here. Beta, this is two beta decimal cancel, beta. So, one C, beta, how much? You can see, beta, 11 by beta, this is 110 by 8. 110 beta 8 beta. How much beta? Tell me everyone. 8 ones are 8 beta and 8 3 8 3 are 24. Beta 24 6 here. Yes beta 13.75. Beta what I can say 13.75 beta. Woman. Sir please no. Okay. Arab don't Islam. Okay. I don't know what all of you are just discussing here. Every beta this is what? Beta I can say 13.7 beta. FV 13.7 minus 3, 11 bacha party. So tension beta, how much will you get here? Tell me everyone. This is beta something 13.75. So beta simple we can say tension is 2.75 Newton. Tension's 2.75 Newton. I'm watching stream in Nokia. Okay. Okay, fine beta. How many have the same answer here for tension beta? 2.75. Anyone from all of you? Arab, Raju, Woman, Sure, Ajita Krishna, anyone? Beta, I got tension beta 2.75 Newton. Student, I got beta tensions 2.75 Newton. Okay, Arab, same answer. Very good. Very good, bacha party. Clapping. Clapping, bacha. Mine is 2. Oh, very good. Arab, beta. God bless you, bacha. Clapping here. Very good, beta. Very good. Very good. All of you doing very good job here. Now, beta, what's in the next part here? Next part, beta. What we have to find, bacha party? If the string is now cut. Okay, beta, this is case 2, bacha party. Arab. Okay. Arab, same bacha, same bacha, same bacha, same bacha. Very good, beta. Very good, bacha. Now, beta, in part 2, beta, what says? A string once cut. Then we have to find what? Acceleration. Then beta, what we have to find? Acceleration here. Simple bacha. You can say for this condition beta, tension is what? 0. Beta, this is what? You can beta mg. Beta, this is what? My dear, you can see buoyancy force. System beta motion remains here in upward. So beta, what you can write bacha party here? Beta, again use your equation of and now Arav is stopper. Okay, fine. Correct, correct, correct. Correct, bacha buddy. So yeah, soon again I'm using bacha. This is what? Summation of beta constant of NLM here, F net is equals to MA beta. So this is what beta F minus mg is equals to MA beta g. We wish to find acceleration here. So you can say F minus mg my dear upon m is equals to A beta. A beta how much here? 1c portion we already calculated with that. 13.75 1 beta mg is what? You can say 10 upon beta 1 is equals to A beta party. So beta this is what coming here? This is A is equals to 3.75 meter per second square. Okay, how? Yes, 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 yes. One new candidate. What's your name, beta? I can say you written something here. Oh, very good. Very super, man. Very good. Clapping. Clapping Arab, Star, Krishna. Very good. Very good. Very good. I'm proud, beta. I'm literally feeling proud on all of you being on, I can say live, all of you responding the questions. Literally, it's a very huge motivation, energy I'm storing in my body. But I wish you all the very best here. But have a look, beta, next question here. My dear, have a look, next question, my dear, everyone. So beta, what's the next question here? Beta, again, you can take same thing, but there is a little changes. Student, there is little changes. Beta, what I can say, diagram beta, I can take as usual. Beta, this is what direction of acceleration, right? But I can see na beta, this is B2 beta, J mean P by Q bacha. Sir Raju is copying. Okay, I don't know bacha. I don't know bacha. Okay, bacha, just have a look at the question same. I can say, beta, this is question remains same. I wanted to do beta next question here based on this. Right. Okay, fine, beta. Hmm. On buoyancy. On buoyancy, beta. Do next question, beta. Ji. This question, beta, same here, repeat telecast. So I don't want to do these questions. Do everyone bacha party? This is what? JE mean beta. Leave beta this question. Next question I'm giving bacha. This is JE 2025. So what is the time of live daily? I can say, bacha, I'll make. I'll give you contact number. Don't worry. End of the class. But usually, beta live I can say for 11th class here in the evening. Beta you can say like 7 to 9. Like after 7 o'clock, beta. After 7 o'clock in the evening for 11th class and night for 12th class, beta live class in the night like 11:30 to 2:30 like that or 1:30, beta, for 12th class. But this is question beta in JE already asked bacha buddy. So what's the question bacha buddy? I can see there is beta mass of cube mentioned bacha. This is the mass of cube bacha ji. This is beta ji 400 gram. You can take beta side length of cube. This is what my dear 10 centimeter. Floats in a water. But there is mentioned here. You can say this is the container bacha. Just do more question, bacha. This is the cube, beta. Just I have taken one surface of cube, bacha. You know, this is not a cube surface. Cube, this is the cube basically. I hope all of you know. But I have taken here one part only, right? One surface. Okay. How much volume of the cube outside the water? Find, find beta, how much volume of volume of cube, volume of cube outside the water, outside the water. Yes, beta. Just tell with everyone here. Find how much volume of cube outside the water. Density of water, beta. All of you know here. Otherwise, I'm writing. You can take beta 1000 kilogram per meter cube. Options beta, I can write here. I can write beta option also. Uh, but I'm not pretty like options beta. 600 centimeter cube. Beta Z 1400 of beta. You can say C. This is beta Z 4000 centimeter cube. And last beta, you can say 400 centimeter cube. Okay. So what is the time of live daily? I said beta. For 11th bacha after 7 o'clock and beta G for 12th class in the night after 11:30. Okay, Arab. Oh, very good. I'm proud of you, Arab bacha. You already answered questions. Arab, very good. Arab bacha, I'll do ya. Wait, beta. Just give me chance, bacha party. Okay. So beta, what questions is here? This is the cube. Mass side is this beta. This is we have to find what is the cube side outside the water. So beta, first we have to find in these questions here. Beta, was make a video bacha. This is my dear. You can say mg force. Yes, Ara beta. Wait, beta. This is the buoyancy beta. You can write my dear at equilibrium. At beta z equilibrium. What beta you can say? This is buoyancy force is equals to weight. Buoyancy force beta, you can say density of liquids V into G is equals to beta, you can say mg. G finish beta G. So density of liquid here already mentioned beta, that is water 1000 kilogram. V beta we wish to find here. Mass beta already mentioned here, that is you can say 400 gram. So beta 400 into 10 to the power minus 3. You can say bacha, this is cancel. Right, bacha party? This is what you can see cancel bacha party. Okay. So you can beta, yeah, just leave it. Don't do cancellation. You can write column beta what? 400 into 10 to the power minus 6. It's a meter cube, which is not answer. Sir, I reject 600 only. Okay, Ara. Very good, beta. But I'm also beta calculating much Ara. That's why I'm doing a beta in front of you, beta. Beta initial volume here. I got here. So beta, you can see this is beta volume submerge. Beta, we used to find volume of cube outside the water. So beta, for this condition, okay, beta. I got this only. Okay, Aditya Krishna, beta. I'll solve it, sir. Beta, this is step one, beta. You can tell my dear. In step two, beta, what I'm solving over here. This is, you can say, volume of cube. I'll do beta. Next page here. Beta. This is volume of cube. Beta, see, volume of cube. This is what, my dear? Outside the water. Right, beta? Okay. Yes, beta. Yes, every day I was coming here. Every day I was coming with study. Also was there like 220 approx. 245 beta. I was also there in 12th class. 12th, today I'll do in 12th class electrostatics. Student today, Bhuman, I'll do in 12th class electrostatics beta. After 11:30, yeah. I'll be there today also. Don't worry. Now, bacha. So volume beta outside, you can see volume actual beta. Beta minus what? You can say beta volume displaced. So beta, what is volume here? Side of the cube, bacha. This is what you can say 10 into 10 to the power minus 2 bacha the cube. minus beta what you can see 400 into 10 to the power minus 6. Maybe I'm right. Yes, beta. So this is what beta you can see. This is 1000 minus 400. My dear, 10 to the power minus 6 beta. So 600 10 to the power minus 6 meter cube. Okay, this answer also correct in meter cube, bacha. Okay, I'll join at electrostatic class. Okay, good beta. You can join, bacha. So volume beta outside beta. What you can see, this is 600 centimeter. Oh, Ara, very good, my dear. Ara beta, how can I call? Ara beta, I see it. Arab, I said beta, I'll give you contact number. Arab, I said I'll give you contact number here only, and I'll erase quickly. Because good student always good only, right? So I'm looking at good candidate. So literally, I can say today all of you performing very well. Sir, then I don't know what you wrote Arab as the last line. Sir, okay, sir. I thought inside water. No, 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 no. Krishna Beta already mentioned outside the water, but sir. Krishna Beta already mentioned outside the water, my dear. Right? Okay, Beta. Have a look here next. Beta. So this is Beta J2025, bacha. This is Beta J2025, bacha. Have a look at the next question here. So what questions is Beta next here? Beta, this question from 2024. Beta, this is JEE beta 2024. JEE beta 2024 beta. Right. Beta, what is this question? This question already I did. Right, beta. So what's question, my dear? Beta, see, you can say there is a container. This question I did, beta. Okay, sir, Raju, I don't. Chapter name. Arab, right, beta, chapter name. Reply, bacha. Someone asking. Okay, beta, I can join. Now, beta, I can say, beta, there is a cube of ice, beta, floats partially. Beta, there are two liquids. This question I did just now, beta, right? But just I'm giving you, beta, because of there is some little data change, beta. Beta, you can see there is a word. Again, beta, I'm considering this is the cube. Student, this is the cube, right, my dear? But here I'm considering surface, one surface of the cube. You can take beta. So this Q beta, you can say partially in the what? Water beta G. And this Q beta what? You can say partially in the what beta? This is kerosene oil. Yes, beta. So this is what? It is density of kerosene oil, beta. This is what? Density of beta. You can take water. Beta, you can see half part is like beta. This is the water and half part beta what? You can see density of kerosene oil. Right, my dear? Okay. Beta, you have to find ratio of volume of ice immersed in water. Beta, you can write find ratio of ice to volume of water, beta, immersed in water. Beta, you have to find beta this only. What's the question here? Yes, beta. The ratio of volume of ice immersed into water to kerosene oil. Okay. So, you can beta, you have to find volume of beta say kerosene oil to volume of water. Yes, beta. So density of kerosene oil. Yes, yes, I'm giving bacha. Beta, they mention not density bacha. They mention bacha specific heat. You can see beta. Then relative density of kerosene bacha. This is 0.8. Beta, see relative density of water beta. This is 0.9. Beta, this is the data mentioned bacha. But in the questions. Again, I repeated the question. This is the container. In this, there is the cube. Few part of the queue under the water, few part you can see in the like kerosene oil. Beta B is to find volume of you can see volume of kerosene to what volume of water, right? Beta relative density of kerosene bacha 0.8 beta, relative density of water 0.9. Okay, how sir water 0.9? Ah, yes beta, correct beta. What is the meaning of thermodynamics over here, bacha? Why you are thinking? I think like thermodynamics here. Okay, anyone, beta, just I'm writing options here. So this is option beta ji, 5 is to 4, 9 is to 10 beta. No beta, in live classes, all of you know student how they are reacting. But here, how smoothly, bacha, I'm just trying to treat each and everyone equally here. Because all of you literally doing a very good job today, beta. Okay. Do you want try beta or how to do beta? Arab, Aditya Krishna, Raju, Bhuman. Okay, Aditya Krishna already answered. Very good. Very good, beta Aditya. Okay, so now yeah, I'm going to solve this question there. Now, beta, I'm going to solve this question here. Okay, beta ji, for this question solution here, I'll beta. So this is a what language of FBD. The first we have to just plan here FBD. So you can see beta, this is the cube. This is what made here. This is the cube. Okay, then beta, you can see for this condition, this is what beta mg. This is what m1 plus m2 into g beta. You can take like that. Right, what's party? Or beta, I can say ice cube, no, only which. So this is better way beta. I can write mg force only. Here beta, I can write there is buoyancy force. One beta buoyancy force due to kerosene oil. One beta buoyancy force due to water. That's all beta. Then beta, just these equate beta these two at equilibrium beta for vertical direction. Beta in vertical direction system is in equilibrium. In beta, you can write vertical direction बच्चा. This is what FV of beta g water plus beta g FV of kerosene oil is equals to beta g mg is equals to beta what you can see. This is what mg. This is what beta g mg. FV beta just write here carefully. So this is what beta density of water into beta g volume of water into G plus beta density of kerosene oil, volume of kerosene oil into G is equals to beta the mg. G and G beta cancel. Density of water, volume of water plus beta density of kerosene plus volume of kerosene is equals to beta m is equals to beta m. Okay, mass beta also I can write here. Mass student also can write what? Density of ice. It's ice beta. It's ice cube beta. This is what my dear, it's a basically ice cube. Density of ice beta into what? You can say my dear volume of ice. You can okay, Arab. Sir, but I put water in kerosene and cube is more water practically. Beta, I'll go through this here. Beta, Raju, beta, wait. I got answer from, I can say, uh, yes, sir, I got theoretically 1:1. Aditya Krishna, 1:1. I can say I took ice density point. Okay, fine, very good. Yeah, I can say everyone has the same answer. Means, according to all of you, answer D is correct. I don't know, bacha. I'll for bacha party. I'll see, bacha, how this is. Beta, I can say this is density of water. Beta divide everywhere here. Just I write once with the density of water, volume of water plus beta is density of kerosene, volume of kerosene with the plus here density of ice into beta volume of ice. Okay, 1:1. Okay. Very good. All of us have the same answer. Then beta give me chance here to solve beta completely. Beta divide all beta density of water. So you can see beta for this condition. What my dear, I can see for this condition. This is volume of water plus density of kerosene oil upon beta density of water beta into volume of kerosene beta plus this is density of ice upon density of water into beta volume of ice. So Raju, which class are you in? Okay, okay. Now, bacha, this is the condition here. Beta, then we'll use here volume of water beta. This is beta volume of water. Beta, this is mentioned for SR, if you remember everyone. For kerosene oil, beta, how much? 0.8. Can I put it directly here? This is what, my dear? 0.8 beta volume of kerosene oil. Plus beta, what you can say? 0.9 volume of ice. 0.9 beta volume of ice. Beta, here, just one assumption you can take, beta. Okay, fine with Chaji. Now, beta, what I can say, volume of ice is what, beta? Volume of water plus volume of kerosene, beta. Just beta, just apply beta this thing, this beta calculation over here. So, beta, volume of water plus, my dear, 0.8 times volume of kerosene is equals to zero point 0.9 beta volume of water plus volume of kerosene oil. So, beta here further I can solve here only. This is the last part. Just open the bracket beta. This is volume of water plus zero point 0.8 times volume of kerosene oil, zero point 0.9 beta volume of water plus volume of kerosene oil. Yes, beta. I can see, bacha, I'm getting same answer here. Volume of, yes, beta. Very good, yaar. Very good. I'm literally feeling proud on you. Oh, very good. Very good, bacha. Very good, yaar. I'm proud on you, bacha, buddy. Beta, don't do bacha any 3 7 here. Yeah, now we are in live and learning here. Very good. Our Krishna, superb student for today class. I can say, bacha. So, beta, which option beta correct here? Option number daily is correct, bacha, party. Okay. Uh, now, bacha, have a look beta next questions here. Hmm. Beta, this is JE beta 2024. Beta, this is again bacha JE beta 2024. Right, bacha ji? Okay. Beta, what's the questions here? A sphere of relative density. I'll write beta questions little. A sphere of relative density sigma. Right, beta? And and diameter capital D has concentric cavity. Has beta G concentric cavity of diameter D. But you need to find the ratio of, it's a literally good question here. The ratio, tricky question. Capital D by small d. If it just floats, if it beta what just float on water in a tank. Okay, do beta everyone here. Uh, yes, beta, you can go. Aditya Krishna, beta, you can go, bacha. But do beta this question, you can go, bacha, buddy. Sir, I don't have you. Okay, okay, Arab. Still, beta, just, I'll beta, just tell me to these questions. This is the last question, bacha, buddy. Aditya, Arab, beta, both of you, beta, just finish this question, bacha. Then I'll beta, terminate your class, bacha, buddy. And also, I'll give you, bacha, contact number. Just beta, answer me this question, bacha, buddy. Answer me, beta, this question, beta, right? Beta, I'll write options. Beta, this is the last question, bacha, for today's session. I'll take one more live session, bacha. There, I'll do discuss a good numerical, bacha, party. Okay. Bacha, I can say this is beta option first. Sigma minus 1 upon sigma to the power beta 1 by 3. Beta, I can say option number second, bacha. This is what? Sigma upon beta. Sigma minus 1 to the power 1 by 3 beta. Option C, bacha. Sigma plus 1 upon sigma minus 1 beta 1 by 3. Last beta C. This is sigma minus 2 upon beta is sigma plus 2 to the power beta 1 by 3. Do bacha everyone here these questions? Right beta? Then here I'll just terminate beta this class. Okay. Raju, options Bombay. Ara option Bombay. Say sir, he is disturbing. You correct Aditya Krishna beta. Okay, it's beta. He'll learn from you. Don't worry. After some time, bacha. Okay, fine. Okay, sir. Bombay, Arab. Okay, Raju. Okay, fine. Everyone here, very good. Beta, this is the last question, beta, for this live session. Right, bacha party? Just, beta, stay everyone here. So, beta, relative density mentioned here for these questions. Right. So beta, what you can say, weight of the sphere is equals to what bacha party? MC only, simple bacha. Weight of the sphere beta, what you can say, simple bacha party, buoyancy force. Right bacha party. So beta, simple you can see this is the bacha ji weight of sphere is equals to beta buoyancy force. Weight is what beta you can say mg. This is what beta I can say rho volume displaced into g bacha. Okay, fine bacha. Uh, I can say all of you literally beta very good. I'm very happy to see beta one request. Be care each and everyone here. So beta, what is mg beta? Density into volume beta. So beta, you know how I wrote here because everyone know what is the relative density. This is what density of material upper beta what I can say uh, density of water beta. So what is the beta density of material beta party? So beta here I can write sigma into density of water. Beta here I can say beta this is what sigma into density of water beta. So beta I use beta. Sir, please give your contact number. Yes, I'll give beta. This I'll please beta. I'll give you beta. I'll give you beta. Sigma into beta. This is beta. This is the thing beta. Okay. Into beta what? 4 by 3 pi 3 beta. 4 by 3 beta. This is pi beta. R this is the diameter here. So it can take beta 1 upon 8 common my dear. This is dq minus beta g dq is equals to beta buoyancy force on the body only beta. So this is what density of water into beta 4 by 3 into beta g pi upon beta dq by 8 into g. You can see beta this density finished beta 4 by 3 pi 4 by 3 pi finished 1 upon 8 1 upon 8 finished, right? You can say beta this is g mixing here, g and g finished. What you have beta finally, this is density beta into beta you can say dq minus dq is equals to what beta g dq, simple beta. Okay, now beta I can say this beta just open the bracket here. So this is sigma into dq minus sigma into dq beta is dq here. Beta just come this side beta party. Then beta you can see this is dq common beta sigma minus 1 is equals to beta sigma into beta this is dq, right? So beta what we wish to find here d by d. This is beta last solution beta party. So it can say beta d by d which is equals to sigma upon sigma minus 1 to the power 1 by 3. Okay. Bombay, correct, yeah, sorry. Correct beta, correct beta, correct beta. I can see there is one more candidate here. Bombay, correct yeah. What's the name here? Sagar, maybe. Yes, beta. All of you are very good. I'm very happy to see. Oh, yeah. Oh, okay. You Raju first. You Raju first. Bombay. Yes, yes. Correct, 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 correct. So, beta, this is all about beta. I can say live session. I'm literally beta very happy to see you. So, beta, just give timing here. I'll, hello everyone. Sir, can you please tell about yourself? Yes, Arab. I am Bajrangi. I did BTech in Makan. Beta, just give number everyone first. Everyone just take number here. Then I'll read Bacha party quickly. This number for you only beta, because no one will watch the video, end of the video. Arab here only. Arab, are you there? Suryans. Arabita. I saw. Okay. Everyone here, just go through this here. Okay. Arabicha, you? Arabita, got it? Arab written? Arab written, bacha? Arab. Arabicha. Student, it's a landline here. Noted. Okay. It's a better landline here. It's a landline, bacha. Right. Okay. I'll erase, bacha. Okay, very good. Okay, bacha. Now, student, I'm going to just stop live session. All the very best. I'm very happy to see each and everyone. Student, stayed physics point, share with your friends, family. All the very best, bacha. All the very best, bacha. Now I'm going to stop live stream bacha party. Yes, Arab. Yes, yes, yes. All the very best. All the very best. Stay tuned at physics point, beta. Stay everyone. Physics point. All the very best.